what we want to do with the house on the solution side is not just, slap on a bunch of solar onto an inefficient house. We really want to maximize the efficiency and bring that annual energy consumed down substantially so that what we need to produce is limited so that it's cost effective and also effective from a space standpoint. So the project that we wanted to do, what our goal was basically to use a project to touch every part of the chain of people that lead to a house happening. And so, from that perspective, we wanted to start with the building industry. We wanted to work with contractors, architects, engineers. We wanted to work with lenders. We wanted to work with realtors. We wanted to work with owners. And we also wanted to work with students. And we wanted to do a demonstration development that basically answered the question of why is this not normal in Chattanooga for all new buildings. If you ask a builder that, they say, well, nobody's asking me for it. I'm only going to build what people ask me to build. People ask me to build houses with granite countertops and wood floors, so that's what we build. But then when we go to owners and say, well, why aren't you asking for this? They say, well, it's not an option. It's not available, which must be because it's either impossible to do or I can't afford it. And so with this project, we've really been able to sort of bridge that gap and show buyers that it is possible, it is affordable, show developers that there's high demand for it, and then show the engineers, architects, and general contractors the sort of simple off-the-shelf technologies that they can use to make it happen. Let's see. So just for those that aren't familiar with Chattanooga, this is where we are in the country. We're about the same distance from Nashville, Knoxville, Atlanta, and Birmingham, so about 2 hours from each of those. We're at this sort of crossroads for both interstates, rail, and the river system. That was what really led to Chattanooga being an industrial powerhouse, but it also is what led to all that pollution. And now, over the last 30 years, our region has been really working hard to both implement strategies to clean up what was done and then also attract new businesses and new opportunities that sort of lead to a different place. So within Chattanooga, this is where the project is located. So where Chattanooga is on this map, that's sort of the downtown, and we're just across the river to the north side. But you can really see the natural assets that our community has. It's a big part of what attracts people to come to Chattanooga and to stay in Chattanooga. At least it certainly did for myself and our family. This is sort of zoomed in even further. You can see that the house is basically walkable to this riverfront area. It's walkable to the commercial strip on Fraser Avenue. Brett, can people see my mouse if I'm using it?
Yeah, definitely. So just be careful with it.
Okay. Yeah. So Fraser Avenue, sort of the commercial strip that's walkable. There's a grocery store right here. There's a post office right here. So, the people that live in these homes can walk to all their basic needs. In addition to that, in the opposite direction, they can walk to a full trail network and mountain biking network on Stringer's Ridge, which is in a conservation easement. the project started in 2014 with a design competition. We had 11 entries from the region, and we had entries from Chattanooga, from Knoxville, from Asheville, North Carolina. We ended up working with a couple teams from the competition to develop the design, and this was sort of the result of that design process. It really started with passive design, so thinking about how to in a relatively compact site in a infill lot, how do you get good passive solar with buildings that are only like 7 or 8 feet apart? We put in basically a clear story to give us access, and we have the south-facing windows shaded in the summer. Sunlight comes in the winter, gives us free heat. On the east face, which is the side of the house that you see right now, is facing east. There's a hillside with trees on the top that shade that exposure. On the west, we left the deciduous trees on the downhill slope of the house that give us shading in the summer, and then when the leaves fall off in the winter, that lets the sun in. We also were looking at the passive ventilation. So the clear story windows are operable and let the wind in the summer that's blowing north create that negative pressure, sort of like a solar chimney, to sort of suck the air up through the lower floors. And from this angle, it's hard to see, but what you're looking at is the upper floor of the house. There's a lower floor beneath that, because it's on a relatively steep slope going away from the road. The next thing that we looked at was having a really efficient, compact design. The floor area sort of guidelines here are from LEED, and so the maximum for 3 bedrooms is about 2,200 square feet. We were able to produce a plan that varies between 1,700 and 1,900 square feet. But you can sort of see there it's a very efficient layout. There's very little circulation space. There's little wasted space. We've really tried to maximize the use of the footprint to reduce the volume of house that we're going to have to heat and cool. The next thing that we did is with the envelope, we did advanced framing. So for those that aren't already familiar, advanced framing is basically using 2x6 studs instead of 2x4s. It increases the spacing to 24 inches on center instead of 16 inches on center. We use header hangers. Those are these little metal things here, and here. Those let you eliminate the jack stud, which you would normally see as a sort of additional studs in the background. And we've got drywall clips at the corners so that we can keep the corners insulated rather than putting extra studs at the corners to attach the drywall to. And we also have ladder junctions where interior walls meet the exterior wall. You basically put horizontal 2x in there to attach the wall to. What this does is really 2 things. It gives us more room for insulation in the cavity, and it also helps reduce the thermal bridging from the interior to exterior. So, the R value of our insulation in this cavity is about R22, but the R value where the stud is much less than that. I don't even know exactly what it is, maybe like R2. And if you think about every stud and in an entire wall and you stack all those up, that's a couple feet of, uninsulated wall. And so if we can reduce the number of studs in the full wall, we help reduce that thermal bridging. The next thing we do is we wrap that with a vapor permeable high performance air barrier. And for this particular project, we used Vapor Shield, and it essentially works like Gore-Tex for a house. So it has a peel and stick adhesive. It has there's a flashing that you put on the windows with a liquid applied flashing that goes to the inside face of the rough openings. But all of it is vapor permeable, which is really important in our climate because it's very humid. It gets very hot in the summers. It gets very cold in the winters. But the longevity of this wood frame construction really relies on its ability to dry out. Some of the oldest structures in this part of the country are the first wood cantilever barns that some of the first settlers built here, and they're still standing because that the wood gets wet, but it then dries. And so as long as it has that ability to dry to the outside, the wood frame construction can last very long. The other thing that people sometimes miss when they do any sort of like high performance air barrier on their walls is they sort of forget about the interface details. So you want to be able to provide a complete uninterrupted air barrier all the way around the house. You want to be able to draw this red line from the vapor barrier that is in our crawl space, that we have a sealed insulated crawl space. We've got a 10 mil vapor barrier down there that goes up the foundation walls, and then that gets spray foamed to insulate it. And then we have an interface detail where that air barrier is basically lapped over the side of the foundation wall and then gets picked up with our Vapor Shield up the wall. And then we have another interface detail at the roof. The other thing is all of these holes that you're poking in the envelope, the windows and doors. We're very careful to make sure that basically that air barrier comes up and into the inside face of that rough opening and then connects very tightly to the windows and then transitions back to the wall. We actually even requested that the window manufacturer, Sun Windows and Doors, actually put in a bead of sealant at the factory inside the window where they add a trim piece just to make sure that we were sort of keeping this air barrier completely continuous. And so the result of that is a very tight envelope. So the first house, the blower door test, which you can see over here on the right, they're working on doing that test for the first house. So they put in this gasket, this red gasket in the front door. They close all the other windows and doors, and there's a fan that's sort of right behind this guy that then pressurizes the house. And then by measuring the volume of air that's being forced into the house at a consistent pressure, you can measure how much air is leaking out of the house. So the first house, we had basically 1.2 air changes per hour. And so those that don't know what that figure means, it's basically at 50 pascals of pressure, the entire volume of air in the house escapes 1.2 times in an hour. And for a traditional house that's built here in Chattanooga, because they're not on the most up-to-date residential codes, they're between 5 and 7 air changes per hour. So that whole volume of air in the house escapes 5 to 7 times. For older homes, that could be in the double digits. And so you can imagine if that much air is able to leak out of the house, the mechanical system has to work really hard to heat and cool that whole volume of air almost constantly, whether it's the winter or the summer. So what we want to do is seal that as tightly as possible so that when we condition the air, we don't lose it. The second house, we got down to 0.6 air changes per hour, which is the passive house standard. The first and second houses were all spray foam. The third house, we actually did spray foam and rock sole, and that one was not quite as tight as the spray foam, but was pretty close. Rock sole is a mineral wool insulation, so you can see here actually what that rock sole looks like. It comes in these sort of slabs and can be basically pressure fit into the wall cavity. It comes at both 16-inch and 24-inch stud spacings. The first two homes, we used open cell spray foam in the rafters and the cavities. We used closed cell spray foam in the crawl space. On this home, we used the spray foam in the rafters, and then used the rock sole in the walls. We also used some rock sole on the interior walls for soundproofing in some places. So heating and air conditioning,
Hey,
you can. Oh, go ahead.
Michael, real quick while we're on the thought of insulation, could you tell us a little bit more about, did you review other options, such as, so the question from the audience here was SIPs, structurally insulated panels, but I'll just toss a few more at you in case you did look at them. SIPs,
we
ICS, insulated concrete forms, or did you look at exterior rigid insulation on any of these at all?
Yeah, that is a great question. I'm glad you stopped me on that. We looked at the entire array of insulation options that's available, and the things that we were trying to do was basically get to this sort of as close as we could to this nexus between cost and performance. And we also are very purposefully using these homes to test some of these different solutions. So you can see actually in the fourth house, we're going to be using blown-in fiberglass in the cavities. And some of the things that were ruled out because of cost. Yes, they could perform better, but the cost difference basically didn't it didn't make sense for our purpose of trying to get to that absolute lowest possible cost for the highest performance. And so structural insulated panels sort of fell into that. And I should say, a lot of almost all of this is really reliant on your local market. So I mean, it's worth, no matter where you are, going through all these different options and pricing them out to see where they come. The structural insulated panels were, somewhat close, but they were sort of just outside of our sort of bell curve. The rigid insulation on the outside, so the continuous insulation, in our climate, in the Southeast and climate zone 4, it's really hard to get that to pay for itself in terms of the incremental performance that it gives you. We actually started the project thinking we were going to do that, but that was where our consultants, Matt Vandy with Vanda Mustard Design, has done a huge amount of work both on the analysis side and on the inspection side, and really just hammered it home that in our climate, the continuous insulation has way too long of a return on investment for it to for us to do it for this project. That's not to say that it wouldn't help. If you want the greenest house, I think that's absolutely a great feature, and it makes a lot of sense. But again, the purpose of this was to try to hit that, what's the sort of the bare essentials to get to net zero energy at the least cost possible.
And I wanted to follow up too a little bit on the concept you mentioned of the local market, and I wonder and I don't know what you're seeing there. I know we're seeing in many places sort of this, just a massive upswing, right? I mean, just things are going crazy, and there's a massive builder shortage, right? So do you think in that context, things that are more pre-manufactured, like SIPs, start to make more sense? Have you been seeing anything like that?
Yeah, I would absolutely agree with that. There's also, I mean, a lot of people might not realize this. There's several different kinds of SIPs. Most people think about your typical wood SIPs with OSB. We've got a couple builders here locally that are building with metal SIPs, and they're doing it at a cost competitive point, but that's because the builder is very, very used to working with them. He came from a sort of industrial manufacturing background, and he can just put them together really fast and really efficiently. So it like you said, it all depends on your local market. Another thing that's starting to affect this are the tariffs that were just put in place on Canadian lumber. So we have a lot of southern yellow pine down in Georgia that we have pretty immediate access to, that's sustainably harvested, and that's not the case everywhere in the country. So from that perspective, that might be another reason to sort of reconsider these different alternatives. One of the things that we really like about Roxol is the sort of balance between performance and environmental impact and health. So it really is one of the healthiest insulation options, along with cellulose. It has very low global warming potential, but it also has inherent fire retardant properties. So for the proximity of these homes, that was actually a code requirement that we had to have one of our north wall had to be 1 hour rated. So Roxol helped us out with that. The blended fiberglass. Oh, go ahead.
Sorry, if you want to finish that thought, I had another question here on insulation.
So the blown-in fiberglass was where so Matt Vandy had sort of recommended that we go that direction, because he, at least in Asheville, they're seeing that as the sort of the best performance for the cost. We couldn't really find good installers here, though. We finally found one company that's willing to do it on our last house, but the first contractor just gave up. I mean, he literally never gave us a price for it, because he couldn't find somebody that was willing to do it. So that's another thing that, if you don't have subcontractors in your city that do some of these things, it becomes very expensive if you start having to pay for travel for somebody out of town to come do it.
So following up on health there, and I'm glad you brought that up, because there's some questions here on the spray foam. And one's pretty quick, and then the other one, maybe you can elaborate more. The first one is, is the spray foam both in the walls, in the ceiling, open cell or closed? But then following up on that question, there are concerns about foam, both in regards to, its environmental impact on the production side and, off-gassing and health issues within the home. So could you speak a little bit more to those?
Yeah, absolutely. And those are all absolutely, valid concerns. And we spell those out to everybody that comes into green spaces that's sort of interested in using spray foam. I think to the first question, so we used open cell spray foam in the walls and rafters. Again, that goes back to the vapor permeance. We want walls that can breathe, and closed cell spray foam is a vapor barrier. So we do not want any closed cell spray foam on our wood walls. Where we do use closed cell spray foam is in the crawl space, where it's encapsulating basically our concrete or CMU foundation walls. So there we want that waterproofing and that vapor barrier to keep moisture from coming up through the crawl space, because it is conditioned and ventilated. On the health side, we required that all of the spray foam be GreenGuard certified. GreenGuard is sort of the highest level of air quality. There's multiple brands that carry GreenGuard certification, but you still have to be really careful about your installers, because even if the product is GreenGuard certified, if the installer doesn't mix the chemicals right, especially for the closed cell spray foam, it can still off gas. And under no circumstance should anybody ever go into one of these homes within 72 hours after it's been installed. And so for those reasons, it's definitely worth trying to minimize, if not eliminate, the amount of spray foam that you use. In some cases, it is still the best product, as long as you're taking the precautions around the off-gassing. So the other concern that we have with any kind of foam, whether it's spray foam or EPS or XPS or any of those, is halogenated flame retardants. That's something that is still I think an ongoing concern with those products.